Hey everybody, welcome back to part 2 of chapter 6, section 2. There's kind of a lot to unpack in this section, specifically this video, so I'll do my best to cover everything as efficiently as possible. Getting started, what's the cube root of 64? That's just 4. You can always type that in to your calculator. I can pull up a list here of perfect cubes, and you would just type in x to the third on your calculator and pull up the table with Control T. But yeah, 64, cube root of that is 4. And then the thing you need to do now is when you have exponents, just divide them, okay? So I'm just going to do y to the 6th divided by 3. 6 divided by 3 is 2. So my final answer is 4y squared. So take the cube root of the big numbers and then divide the exponents when you have exponents, the little numbers. So number 2, what's 4 divided by 4? 1. What's 8 divided by 4? 2. Instead of writing x to the first power, you could just simply write x over y squared. But that's all there is on number 2. Now number 3, there's a bit more going on with it, and that's you're trying to divide each exponent by 5, and 4 does not have a fifth root. So what you're going to do is you need to think in terms of in numerals of 5. Yeah, am I saying that right? In other words, count by 5s, 5, 10, 15, 20, 25, and so on. So the reason why you want to count in terms of 5 is when I'm doing a to the 8th divided by 5, that doesn't really make a whole number. But a to the 5th power divided by 5 does make a whole number. And a to the 5th power is inside of a to the 8th power, because a to the 5th power times a to the 3rd power is a to the 8th. So you might be asking, well, I still don't get it, or saying something like that. So let me say this. A to the 8th is 8 a's written right next to each other. So I can just group together 1, 2, 3, 4, 5, and then group together the other ones, a to the 5th and a to the 3rd. And so by doing that, I still have a to the 8th, but a to the 5th is at least divisible by 5. So with this b to the 14th, well, 14 is a bigger number, so I'm not going to use 5. I'll use 10, 5, 10, 15, 20. So I'll use b to the 10th and b to the 4th, okay? And with the c, well, c is to the 5th power, so when we divide it, that'll make c to the 1st power. So let's just go back to this. How do I take care of the a's and the b's? Well, the a to the 5th power turns into a to the 1st power, because 5 divided by 5 is 1. And the b to the 2nd power turns into b to the 10th power, turns into b to the 2nd power. It's getting ahead of myself. So what I have in blue here, a, b squared, and c, that can all go on the outside, because what you take the root of, you go on the outside. So I'm going to put a, b squared, c. I don't have to write the power of 1. What you have left over, a to the 3rd, b to the 4th, and 4, this is what you have left over, that can go back on the inside of that radical. So I'm going to write 4, a to the 3rd, and b to the 4th. And that's my final answer with that one. So the takeaway is, if you can't divide it, if it doesn't make a whole number, split it up and use 2 numbers, and one of those can be divided by whatever is outside the radical, okay? So looking at number 4, it's going to be a similar thing. The first thing you want to do is rewrite this as x over the cube root of, and then you got to think factors of 3, 3, 6, 9, 12, or numerals of 3. So I'm going to use 6. Y to the 6 times y squared. All right? Y to the 6 times y squared, well, this y to the 6, 6 divided by 3 makes 2. So I have x over y squared. That goes on the outside now. And then I have the cube root of y squared left over. Okay? So, unfortunately, we're not done with this. You can't have a radical on the denominator or the bottom of your fraction. So because of that, you're going to have to rationalize it. So what I mean by rationalize is, now we need to multiply it by something to get rid of that radical. So I have the radical is the third root. I'm going to have to multiply it by the third root of something because that's what the radical is. It's the third root. Now I have y squared in there. So the next highest number that can be divided by 3 is 3. If I just somehow make that y squared turn into a y to the third power, then I can divide that by 3. Well, y squared times y makes y to the third power. So if I multiply it by the cube root of y over the cube root of y, that'll give me x times the cube root of y over y squared times the cube root of y cubed. Well, instead of writing the cube root of y cubed, that's just going to be y, right? 3 divided by 3 is 1. And what's y squared times y to the first power? That would be y to the third power. So I have x cube root of y over y to the third power. And that is officially my answer on that one. Okay? Okay, so number 5, you have a division problem. 14 over 2 makes 7. You have x over x to the 3/4. So I can write that as x to the first power minus 3/4, because when you're dividing with like bases, subtract the exponents. I have y to the 1/3 over nothing. That has a y with it. And then you have z to the negative 6. Well, anytime you have a negative exponent, move it to the other side of the fraction. So if it's on the bottom, move it to the top. Now it's a positive exponent. If it's on top, move it to the bottom. Now it's a negative exponent. So I have this. And I'm almost done. What is x to the 1 minus 3/4? Well, just turn 1 into the common denominator of 4. So that would be 4 over 4 minus 3 over 4 equals 1 over 4. All right, here I can write x with it right there and there. So my final answer is 7 x to the 1/4, y to the 1/3. Everything else stays the same, z to the 6th, and that's my final answer for number 5. Number 6, well, you have a subtraction problem, but you can't subtract until like the radicals are exactly the same. So I have 2z to the 5th in one and 54z squared in the other. So what I need to do is I need to somehow simplify this. Well, z to the 5th can't be divided by 3, but you can split it up into saying the cube root of 2z to the 3rd times z squared. And because I can do 3 divided by 3, and 3 plus 2 makes 5, okay? So this is going to turn into 3 divided by 3 is 1, so that's going to turn into just a z, and it goes on the outside. And then everything else that's left behind stays behind on the inside of that radical. Now I just need to fix the term on the right side. So I am minusing z to the cube root of, well, I have 54z squared, so I already have a z squared, and I know 54 is an even number, so I can cut that in half. Well, what times 2 is 54? That's 27, or what's 54 divided by 2? So if I say this is 27 times 2z squared, that's the same thing as 54z squared, and guess what? I can take the cube root of 27. That's going to make 3. So I'm going to put it on the outside, and then that z was on the outside with it already. So it leaves behind a 2z squared, just like I had on this one. So now I have the same exact radical, the cube root of 2z squared. So I just need to do 12z minus 3z. Well, that's 9z. And then everything else just carries down, and that's the final answer. Now this next section, we're going to rationalize and simplify with conjugates. So let me tell you what it means to do that. You have a square root sign on the bottom, and you can't have a square root sign, or I should say a radical on the bottom. So to get rid of that, all you do is multiply by the conjugate. And what I mean by that is write the exact same thing down, except if there was a minus in the middle, now there's a plus in the middle. If there was a plus in the middle, now you put a minus in the middle. So just flip the sign, okay? That's basically all you need to remember to do. Flip the sign and put it over itself. At this point, you can just distribute, and I'll show you the long way first. But this is, well, the top is just always going to be distribute. X times the square root of x plus 1 times x is x. And that's going to be over. What you have on bottom is the difference of two squares. Okay? So I'm going to write difference of squares here. And your difference of squares pattern is really simple. It's ultimately just square each term. So square root of x squared is x. Square root of 1 square root, I'm saying square. Square root of x squared is x, and 1 squared is 1, and throw a minus sign in the middle. That's really all you need to do. This is actually the final answer, believe it or not. That's how quick these can be. Once you learn the patterns, okay? I could explain it further, but it's really easier just to go about it with the patterns. Know what the conjugate is. That's looking at the bottom and then writing it with the opposite sign, putting in a fraction over itself. So I'm just multiplying by the conjugate. I'm distributing the top, 1 times 5. Well, it's going to be the same thing. And then the bottom is going to be squared, because this is your difference of squares pattern. 5 squared is 25. Square root of 3 squared is 3. Throw a minus sign in the middle. 25 minus 3 makes 22. So the final answer is this over 22. Okay, let's do one more example. I'm going to do the conjugate, so I'm going to write square root of 7 plus 2 over the square root of 7 plus 2. All right, so since it's times 1, it's not going to change anything, so square root of 7 plus 2 again over, square both of these. If you square a square root, just leaves that number. 2 squared is 4. Don't forget to put a minus sign in the middle. Always put a minus sign in the middle for that step. And 7 minus 4 is 3. So the final answer is square root of 7 plus 2 over 3. Thanks for watching. Bye. Sorry, I just realized, because I did a cut, that I said I was going to show you the long way first, and then I said showed you the short way. But I think you're okay with that. I'm okay with that. So just, yeah, that was the short way. I don't want to make this video any longer by doing the long way, but I just wanted to point that out. All right, bye again for real this time.